All right, today we are going to be doing Chapter 1, Section 5 in Algebra 1. Our essential question is how can you use a formula for one measurement to write a formula for a different measurement? Sometimes these are called literal equations. You use this a lot in science where you've got an equation with multiple variables, and sometimes you're going to want to solve for a different variable than what's already solved for. Let's go ahead and do some examples. So here, I've got 3y plus 4x equals 9. I want to solve for y. And if you've noticed that they've highlighted that y blue, what we're going to do is we're going to move everything around that y and keep the y by where it's at, but everything around it moves. So there's our original equation. What we're going to start with is subtracting 4x from both sides because we want to get rid of that 4x. And if you notice, 9 minus 4x is not like terms, so you can't combine them. But 4x minus 4x is 0, so I'm going to be left with 3y equals 9 minus 4x. Well, I still have that pesky 3 in front of the y. To get rid of that, I have to do the inverse operation. So the opposite of 3 times y would be to divide by 3. So I'm going to divide each side by 3. That means that 9 is getting divided by 3, and the 4 is getting divided by 3. So y is going to be equal to 3 minus 4/3 x. All right, let's do one where we've got an x, and it's actually in 2 locations. What I notice right away is I've got a 3x and a 5xz. Those are not like terms, so those cannot be combined. But then I'm a little perplexed because I've got an x and an x. So I kind of have to figure out what am I going to do? Well, I'm actually going to take that x out, do the opposite of the distributive property, because x times 3 gives me 3x, x times 5z would give me that 5xz. So now I have 2 factors. I have an x and a 3 plus 5z. I'm going to divide by that 3 plus 5z. I'm going to end up with y over 3 plus 5z equals x. And I'm not going to get too concerned or think that I've done something wrong if I get an answer that looks kind of complicated. Sometimes that's going to happen. I'm going to end up with some weird looking fractions here. It doesn't mean I've done something wrong or incorrect. It's just what it is. In this case, x equals y over 3 plus 5z. All right. Why don't you take a second and hit pause and try and solve for y in those first 3. I'll give you a hint on the first one. I would add your x and divide by the number in front of the y. Here I would subtract 2x, divide by -2. Down, go ahead and try 4 through 6 as well. Here, you're going to have to do the opposite of the distributive property. You're going to take that x and you're going to get x parenthesis 5 minus 4. Actually, you probably could have combined those like terms too. All right, go for it. I think the one that's probably the trickiest here is number 6. What I would do is start by subtracting 3 from both sides. You'd have -3. What happens are those 3's cancel, so you've got 5x minus k x equals y minus 3. You're going to do the distributive property, take that x out, and you're going to be left with 5 minus k equals y minus 3, which then they divided both sides by that 5 minus k. And that's how they came up with that answer. Y minus 3 over 5 minus k. If you want to, come into Math Lab or iPass, and we can do some more ones like this. All right, let's go ahead and do a word problem. It's kind of a word problem. So we've got the formula for surface area of a rectangular prism. Surface area is you find this area of all 6 sides, and then you add it up. So on this one, we want to solve for the length, the L. And if you notice, the L is in blue, so we're going to move everything else around it. So there's our original equation. And we want to get rid of that 2WH. We're going to leave everything with the blue right now where it's at. So subtract 2WH from both sides. Those are not like terms, so we can't combine them. And we're going to be left with S minus 2WH equals 2LW plus 2LH. Those are not like terms, so we can't combine them. But I notice, hey, they each have an L. So I'm going to use that distributive property and pull out that L. Well, now I've got 2 factors. L is my first factor. 2W plus 2H is my other factor. Now, a factor is something that's being multiplied. So I'm going to divide by the factor of 2W plus 2H. And those 2 factors are going to cancel out. And I'm going to be left with S minus 2WH all over 2W plus 2H equals L. And that is going to be my final answer. So on this one, I've got a rectangular lot that is 500 feet deep and has an area of 100,000 square feet. To pay for a new water system, you are assessed $5.50 per foot of lot frontage. Find the frontage of your lot. All right, why don't you take a second and pause and try this one on your own. So whenever you do this, it's always good to have a picture. It's rectangular, and we know for the area for a rectangle, it's length times width. So we need to find that width. So that's just going to be 100,000 divided by 500, which is 200. So the width is 200. The frontage of your lot is 200. And then each foot of the frontage costs $5.50. So you're going to take $5.50 times 200. So that's going to be $1,100. All right, the area of a triangle, we want to solve for H. So we're going to start with area equals 1/2 base times height. And that H is what we're solving for. I'm going to kind of highlight that. A lot of times I'll just highlight it mentally in my head. And I want to get rid of that 1/2, and I want to get rid of that B. Well, to get rid of that 1/2, I'm going to multiply by the reciprocal, which is 2. And when I do that, I'm going to be left with 2A equals B times H, which you want to then divide by B. And those B's are going to cancel, and you're going to get your height is 2A over B. So on the next one, you've got surface area, and you're going to want to solve for L. So surface area is pi r squared plus 2, I'm sorry, didn't mean to write 2, it's pi. Pi RL and I'm going to move everything around that L. So I need to start first by subtracting pi r squared. We can get S minus pi r squared, and I kind of did this one a little bit more mentally, but I subtracted pi r squared from both sides equals pi r L. Now about this time you need to be asking yourself, what am I going to divide both sides by? Well, I would do pi r. So you're going to get S minus pi r squared over pi r. That's what happens. Pi's cancel. Those r's cancel. All right. Here are some real basic formulas in science that you just need to know. We're going to have word problems that come up. And I think we've already had the distance word problem come up. And you just are expected to know these formulas. First one is the temperature formula, simple interest, and the distance. These are ones that you want to make sure you kind of have memorized. You've probably seen these before, but now at this level of math, make sure you have them memorized. They're going to refer back to them every once in a while, and they're just going to expect you to know them. So if you need to, hit pause, get them down. So we want to solve the temperature for F. They gave it to us in terms of C. So what we're going to do is we're going to write down our temperature formula. To get rid of that 5/9, you multiply by both sides by that reciprocal, which is 9 over 5. That's where that 9 over 5c comes from. And when you multiply this side by 9 over 5, those are reciprocals, so they cancel each other out. Now, I've got that minus 32. So I'm going to have to add 32 to both sides. And I'm going to get 9/5 C plus 32 equals F. So now I've got the temperature formula solved for F. So let's take a second and apply that. Which has a greater surface temperature, Mercury or Mars? Well, you have to look at this real carefully, because if you look at it too quickly, you're going to go, oh, that's super easy. But then you notice, hey, one's in degrees Celsius, one's in degrees Fahrenheit. In order to compare, they need to be in the same units. So we're going to convert the Celsius of Mercury to degrees Fahrenheit. So we've got our formula. You're going to take out that C and put 427, and you're going to get 800.6. So Mercury is 800.6 degrees Fahrenheit. Well, that means Venus is warmer. All right, take a second, hit pause, try this one on your own. When you are ready, hit the pause button again and check your answer. Nope, you don't have a fever. All right, let's do one with simple interest. You deposit $5,000 into an account that earns simple interest. After 6 months, the account earns $162.50. What is the annual interest rate? So we've got I equals PRT. So we want to solve for R. So we divided both sides by the P and the T. We plug in what we know. Our ending amount, it accrued $162.5. We started with 5,000, and 6 months is half a year. That's kind of tricky. You need to take that 6 months and convert it into years. Then it's just a matter of plug and chug. Put that into your calculator. And remember, percentages, you need to move that decimal point. It's 6.5%. And that is a reasonable answer. All right, a truck driver averages 60 miles per hour while driving freight to a customer. On the return trip, the driver averages 50 miles due to construction. The total driving time is 6.6 hours. How long does each trip take? Well, we're going to have to use the distance formula on this one. And we're looking for time, so we need to solve for t. That means you need to divide by r. So you get d over r equals time. We're going to use these expressions and the total driving time to write and solve an equation. So the distance divided by time plus the distance divided by, d over rate plus d over rate equals the total time. D over 60 plus d over 50. You have to get a common denominator. This one's a little bit tricky, so you needed to multiply that by 5 over 5. And that one by 6 over 6. That's where that 11d comes from. Multiply both sides by 300. Divide by 11. The distance is 180. So the distance one way is 180 miles. Using the expression from step 1, find trip times 2. 3.6 hours. 3 hours there, 3.6 hours back. All right, take a second, hit pause, try these two on your own. When you are done, hit the pause button again. So the first one is $2,500. The second one, 3 hours for delivery. The return was 4 hours. All right. Again, if you need to, come into Math Lab or iPass. Hope you enjoyed.